Good morning, Mr. Tivang. Today I will present about the decorator design pattern, which is the most commonly used in the object-oriented programming. In this presentation, I will briefly explain the purpose of the decorator pattern, its structure, and some its key characteristics. Our group have four members: me, Võ Hữu Lộc, Nguyễn Hoàng Lâm, Lê Vũ Khiên, and Ngô Việt Hoàng. So our presentation will divide into a part. The first one, introduction, structure, characteristic, application and consequence, advantages, limitation, related pattern, example, and the final is a demonstration. So first I will introduce the purpose of the decorator pattern. The main goal of this pattern is to add new behavior to an object dynamically at runtime without modifying the original class. So additionally, in object-oriented design, developers often use inheritance to extend the functionality. However, this approach can easily lead to a problem called class explosion. This means many subclasses are created just to represent for the different combination of its feature. So the decorator pattern will solve this problem by using the object composition instead of inheritance, and it's also follow the open close principle in the solid principle. For example, imagine a notification system. Initially, we have an email notifier. Later, users request additional notification methods such as SMS, Facebook, or Slack. So instead of creating many subclasses like email SMS notifier, email Slack notifier, we can just simply wrap the basic notifier with decorators, such as Slack decorator, SMS decorator, and email decorator. Next, let's look at the structure of a decorator pattern. The pattern will consist of five main participants. The first one is the component, which defines the common interface. The second is the concrete component, which will provide the base functionality. The third is the decorator, an abstract class wrap a component object. The fourth is the concrete decorator, which means it adds specific behaviors to the component. Finally, the client is responsible for configuring and combining these decorators. So together, these participants allow us to extend the object behavior thematically without changing the original class. Now let's start with the component. The component is usually defined as an interface that declares the common methods by use both the core object and the decorators. So for example, in a notification system, which the component could be the notifier interface with the method called send. So the main purpose of this interface um, is to ensure that both decorated object and the non-decorated object share the same structure. Because of this, so the client can treat them in the same way without needing to know whatever object is decorated or not. It doesn't matter. Next, the concrete component. This is the original class object that implements the component interface and provides the base functionality. In our notification example, the concrete component is the email notifier. Its responsibility is simply to send a notification through mail. Before any decorators are applied, this classes already provides the core behavior of the system. Later, additional functionalities such as SMS or Slack notification can be added by wrapping with this object with the decorators. Finally, let's look at some characteristics of the decorator pattern. First, dynamic behavior extension. This means we can add or remove responsible from the object at runtime, which is more flexible than interface. Second, recursive position. Mutable decorator can wrap the same components sequentially, forming a stack-like structure where each decorator has its own behavior. The third, granular decomposition. Each decorator handles a specific responsibility, which follows a single responsibility principle in the Solidgear, and improve the code maintainability. And last, the patterns allow us to extend the functionality or the subclasses. Seeing decorator rely on interface rather than inheritance. We can add behavior without needing subclasses, the original class. So now we will move to the part 4.
My name is Nguyen Lam, and now I will talk about the application and consequences of decorator pattern. Okay, so first to talk about the application, we need to know when to use the decorator button. The decorator button is used when we want to add extra behavior to objects dynamically. Instead of modifying the original class, we can extend the functionality by grabbing the object with the decorators. This will help us extend functionality without changing the existing class, which is useful when the original code should be remain stable. And another reason to use this pattern is to avoid creating too many subclasses caused by inheritance. If inheritance is used for every feature combination, the number of subclasses would be too much. And with the decorator button, features can also be combined or removed at the runtime, which makes the system more flexible. And finally, the button maintains encapsulation because the original interface stays the same while the behavior is added. And now we will talk about the consequences. So there will be the positive effects and the possible drawbacks. To talk about the positive effects, it will be flexible behavior extension at runtime, allowing objects to gain new responsibilities easily. And the button also avoids large inheritance hierarchies, especially in complex systems, and it also supports better separation of responsibilities between the components, since each decorator focuses on a specific feature. And because of this structure, the system can also improve maintainability and scalability. But however, there are also some drawbacks. The button can create many small objects within the application structures, and the object structure may become harder to understand and follow, especially for the beginner. And debugging may be more complex because of the decorator layers. Okay. And next, I will talk about the advantages and the limitations of the decorator button. Okay, so one advantage is that it provides a flexible alternative to inheritance. Uh, the coder can extend the functionality without modify the existing classes, and the button also avoid large inheritance hierarchies, which keeps the design simpler. Uh, and Another benefit is that it allows dynamic feature combination, which means different behaviors can be added together depend on our system. And um, and lastly, the decorators also maintain the same interface between components and decorators, so clients can interact with them in the same way. However, there are some limitations for the decorator button. It can create many small objects in the system, which may increase the complexity, and debugging may also be more difficult because the final behavior depends on multiple decorator layers. And lastly, the design may be hard for the beginners to understand, especially when there are many decorators are combined. So the next one is related patterns. So there are three related patterns to the decorator button, which is strategy, composite, and the adapter. And the first one, to talk about the strategy, uh, both buttons use composition instead of inheritance, but the difference is that strategy selects different algorithms at the runtime, but the decorator adds new responsibilities to uh, the objects dynamically. And the second button is composite. Like the decorator, both buttons have a similar structure using like a recursive object composition. However, composite is used to represent three structures of object, while decorator is used to add extra behavior to individual objects. And lastly, uh, the adapter changes the interface of an existing object, while the decorator keeps the same interface but extends behavior. And that's the end of my part.
Uh, Hello, Mr. Tivan. So I will cover the example part of this presentation. In this section, we have three examples: a car manufacturing system, an invoice processing system, and enterprise application features. Each shows a different domain, but they all share the same core idea. Instead of modifying the original object, we wrap it layer by layer and to add new behavior. Uh, let's start with the first example. In, in this example, we want to imagine uh, if we wanna to build a car where the different engines type can be added. The straightforward approach will be create a class for each combination. A car with petrol, with diesel, or a car with electric, and so on. Uh, this will be a maintenance nightmare. With the decorated pattern, we have one clear base object. A BMW car is knowing nothing about engine. It's just the car. Then we create petrol engine decorator and diesel engine decorator. Each one grabs the BMW car and add engine behavior on top. Look at the diagram on the right. You can see a nested boxes. The outermost box is the last decorator applied. The innermost box is the original car. The key takeaway here is the open-close principle. The car is open for extension through the decorator, but closed for modification. We never touch the original class. Now let's look at something even closer to everyday software, an order or in an invoice processing system. Uh, this will be about when you shop online, you add an item to your cart, and then the system calculates shipping, applies your promo code, and add text. Each of these separate concern in a decorator pattern. Each one separate. Each one is a separate decorator layer. Uh, Here is how it's flow. We start with the core invoice, just an empty invoice. Then the product decorator wraps it and adds the list of items. The shipping decorator wraps that and calculates the delivery fee. The discount decorator apply the promo code. And finally, VAT decorator computes and add a text. The final invoice is stacked results of this decorator. What makes this powerful? Each decorator is completely independent. You can reduce the discount decorator on a different invoice tab. You can test the VAT decorator in isolation, and most importantly, you can mix and match the order. Apply text before discount or after. No change to the core invoice required. The third example is probably the most relevant if you work with any backend framework enterprise application feature. When an HTTP request comes in, what happens before your actual business login runs? Typically, the system checks the cache, verify encryption, authenticates the user, logs the request, and then the core service handles it. In the decorator patterns, each of those steps is a wrapper layer around the core service. Look at the onion diagram. Caching decorator on the outside, then encryption decorator, then auth decorator, then logging decorator, and finally core service at the center. Uh, this isn't just theory. These are real framework you use every day in Spring Boot. Annotation like transactional and cacheable are decorator based in Express.js. Every app use middleware core is essentially a decorator wrapping your request handle. In the Django, the login require and cache-based decorators literally use Python decorator syntax. In ASP.NET Core, the entire middleware pipeline is built on this pattern. These are what we call cross-cutting concern behavior that cut across the entire application but don't belong inside the business logic itself. Decorator pattern is exactly the right tool for this. So to wrap up, all these examples follow the exact same structure. A base object that handle the core responsibility, decorator that wrap it and add behavior, and final enhance object a final enhance object that the client use. Whether it's a car engine, a billing rule, or an authentication check, the pattern is always a base object. Wrap with decorator and show up a final result.
So hello, my name is Hans, and I will demonstrate our project is pizza ordering system using the decorator pattern. So the problem we often face that how we add a feature to an object at runtime without changing its code or creating a huge tree of subclasses. So the decorator button will let us wrap an object at runtime with an extra behavior, so we can keep things flexible and small. So this is our UML class diagram. First one, iPizza interface is our component. This is a contract that every pizza can show get its cost and description or name and get the pizza image. The left one, basic visual, is our concrete component. So it have a fixed cost 50 and an image that didn't have any topping on it. The right one is the topping decorator, or we can say that the base decorator. So it's also implemented in Ibiza image. So you can say that this is a wrap pizza in the topping decorator. So the three bottom one is our concrete decorator. We have cheese decorator, pepperoni decorator, and mushroom decorator. Each one have their own cost, image, and description on them. So let's see the code implementation. We have here is the topping decorator. As you can see, we have in pizza in the constructor. So this one is wrap pizza. This on the method, so we can override in the concrete decorator. So each decorator will have a get description, get cost, get image to that specific one, and it will get the wrap pizza and plot that information to it. So let's run the application. So I have here, so let me ask the cheese and pepperoni. So how our code work? So all the decorator button work. So we have basic pizza, right? When I add cheese in this, so I call it cheese decorator. So it will grab the basic one, and we will add the image on it. So when I call the pepperoni decorator, it will grab the cheese and cheese, it will grab a basic cheese pizza. So you can see it is recursion one. So similar to this, when this one is summary one, it's the name of that pizza. So so this one we call a get description of the top one, the top topping that we add. So that topping we call the graph pizza description one, and add that description on. But similar to that, it will call the cheese decorator. The cheese decorator we call a basic pizza decorator. So the final result is basic pizza, cheese, and pepperoni. So we also see the pizza as a stack, so we can like undo whenever we want. So you can see here, when I add any topping, it will take the big one or the top pizza, the top slice, and wrap it with the new decorator. So whenever I want to undo, or I don't like this topping anymore, I can undo it. It will pop the top stack or the big one out. So I can add any topping as one is the decorator feature, right? So when I don't want it, I just undo, or I reset the whole thing, add it again, and the right and the summary will just call as a recursive one like this one. Yep. So that's all our application. So whenever we want to add a new topping, we just create a new decorator. We have that description, code, and image. That's all. That's the feature of decorator button. Thank you for listening.